In this video, we will input the reactor and reaction specifications for our Rplug reactor. Under the reactor type, select adiabatic. Recall, adiabatic means that no heat or mass transfer will occur between our reactor and its surroundings. Next, move to the Configuration tab. Here, we need to specify the reactor dimensions. Let's set that to 5 meter for length and 1 meter for diameter. These values are as a first approach. Recall, we will target a conversion rate for acetone of 20%, and so we might come back here later and change these dimensions. We'll see this in details further ahead. Now notice here that our reactor is chosen as a single tube reactor, a cylinder with a length of 5 meters and a diameter of 1 meter. You may choose, however, a multi-tube reactor by ticking this box here. For instance, you can specify 100 tubes of length 2 meters and inside diameter of 1 inch. But in our case, we will choose a single tube reactor. Next, for the valid phases and under process stream, keep vapor only, because with our input for pressure and temperature, our components are in the vapor phase. So actually here, our Rplug flow reactor is a gas phase reactor. Now, before moving to the Reactions tab, let's move to the Pressure tab. Here, there is something I want you to know. Notice here that if the inlet pressure value is left at 0 atmosphere, then we will instruct Aspen Plus to let the inlet pressure to be equal to the feed stream pressure, which is our case here. So here we will leave 0 atmosphere. Now, if you click on Reactions tab, you will notice that you need to associate a reaction set to our plug flow reactor block. However, since we did not define yet any reaction, the available reaction sets side will be empty, as you can see here. To create a reaction set, click on the button New. Then rename your reaction or keep the default name suggested by Aspen Plus, then click on OK. For the reaction type, in this first section, we deal with reaction with simple kinetics, what is called power law type reaction in the Aspen Plus terminology. So click here to expand the list, then select power law and click on OK. Notice now that our reaction set is added to the right reaction box. Now, the reason for describing R1 as a reaction set is simply because it may contain more than one reaction. Here we have only one reaction as depicted here. Acetone is cracked to yield ethanone or ketene plus methane. Now click on the next button and Aspen Plus will bring you to the Reaction Set tab, as you can see here. In this tab, we need to specify the stoichiometry and kinetics for our reaction. Under Stoichiometry tab, click on New. This will open up the Edit Reaction window that you can see here. Here we will define the reaction equation and tell Aspen Plus whether our reaction is of the kinetic or equilibrium type. Now, since our reaction is first order with respect to acetone, as stated in the process description at the beginning of this section, then it is a kinetic type reaction, so select kinetic. Notice now that this window is broken down into two parts. The left-hand part is for reactants, and the right-hand part is for products. Based on our chemical reaction, which you see here, our reactant is acetone, and our components are ethanone and methane. So let's input these data by selecting the components from the drop-down menu. So, under Reactants, click here and select Acetone, and for products, click here, select Ketene or Ethanone, then Methane. Now, for the coefficient that you can see here, these refer to the number you may find in chemical reactions next to each species. In our case, 1 acetone yields 1 ethanone and 1 methane, so the coefficients here are equal to 1. Be careful though, for reactants the coefficients are input with a negative sign, indicating that these components are consumed during reactions. So for acetone, type in here -1. Products, on the other hand, are entered with a positive sign, indicating that these components are being produced. So for ketene or ethanone, type in here 1 and 1 for methane. Finally, for exponent that you can see here, input 1 for all components. So 1 for acetone, 1 for ethanone, and 1 for methane. Once you have done this, click on the next button. You can see now a blue check mark next to the stoichiometry tab, indicating all required input are now complete. Next, click on the kinetic tab. Here you need to input kinetic parameters such as K, N, E, T0 if applicable. Recall, these parameters were covered in a previous video. But before entering these parameters, change the reacting phase that you can see here to vapor. Because if you recall, under the specified pressure and temperature, all of our components are in the gas phase. Then leave the rate basis as suggested by Aspen Plus on the volumetric base. Now for the power law kinetic expression, recall that in a previous video we have defined two equations for our reaction rate. These are highlighted here for a reminder. One of them includes a reference temperature, denoted here as T0, and the other one does not. These two equations are of course equivalent. To enter kinetic parameters, you can choose either equation. In my case, I will choose the second equation, and so input here 8.19733 exponent plus 14, 0 for N, and for the activation energy 2.84522 expressed in kilojoule per mole. And T0 will be left empty. Okay, notice now that the simulation status has changed to required input complete, indicating that Aspen Plus has now all the required input parameters and is ready to run the simulation. So let's move on to the next video to run our simulation and explore our results and check whether or not we meet the conversion rate of 20% for acetone.